Good day, my students, and welcome. Chapter 2. The focus of this chapter is on hardware. You need to differentiate between hardware and software. You should also be able to give me examples of hardware devices and software devices. Understand that there are many different components of a computer system which will help you to work more effectively and efficiently. The learning objectives in this chapter are, basically you need to know what's the central processing unit, the CPU, the motherboard, the parts of the computer, basically, the system unit, right? Control unit, arithmetic logic unit. Describe the input devices and what are their uses. Don't get confused by a monitor that can be both an input and an output device. I think I spoke to you about that in class. The monitors at the KFC or the McDonald's. Describe the output devices and their uses. Compare printer types. And I think in class I asked you to kind of identify what are the factors you need to consider when buying a printer. Discuss some of the communication devices. Compare storage devices. Explain the functions of the central processing unit, right? So, a computer basically does four basic tasks: input, processing, output, and storage. And if you were doing programming, that's what I'll be talking about as well. But we're not doing programming. You are CPIT 101 students, and it's basic computer literacy. What are the functions of the central processing unit? Now, the central processing unit, you can think of it as our brain. We have a brain, and the computer has a brain or a processor, and this is located inside of the system unit on the motherboard. It consists of two parts, the arithmetic logic unit and the control unit. The arithmetic logic unit performs arithmetic and logic calculations. For instance, it will determine whether one number is greater than another number, one number is less than another number, or even equal to that number. The control unit coordinates the movement of data through the CPU. These two parts of the CPU enable it to execute the program instructions. Explain the function of the central processing unit. The instruction cycle or machine cycle processes each instruction in the CPU, the central processing unit. During the fetch operation, the instruction is retrieved from the random access memory, RAM. Remember, I spoke to you about RAM and ROM, read-only memory. Note the difference between the two. The decode step translates the instruction into a form that can be understood by the CPU. In the execute step, the ALU processes the arithmetic operations and logic decisions, producing either a number or a value of either true or false. The store operation moves the results back to an internal register or memory location for future use or storage. Now, I think I spoke to you about this as well, and we identified the speed of our computer. We're talking about computer speed, multi-core or dual-core, and graphics processing unit. Billions of instruction cycles are executed each second by the processor. The measurements of the clock speed can be used to evaluate the processor's performance. The unit measurement used for clock speed is gigahertz, with a 3 gigahertz processor executing 3 billion data cycles per second. Multi-core processors increase the number of data cycles that can be run each second by putting 2 or more processors on a single chip. Dual-core, quad-core, and even 6 and 8-core processors are found on personal computers, all increasing the speed of the system by multitudes. Many video cards also have a processor to help take the load of processing the graphics of the computer processor. A graphics processing unit, or GPU, also contains multiple cores. The more instructions that can be processed, the higher the performance and efficiency of the computer. By pipelining, multiple instructions can be processed simultaneously. Using an assembly line analogy, each instruction is processed through one step of the CPU cycle as it progresses to the next phase. A new step enters into the pipeline. This means that 4 instructions are in some stage of processing at one time. Parallel processing increases the computer performance by dividing processing tasks between multiple processors or multi-core processors. Excessive heat builds as multiple processors work, and the heat generated by the CPU could eventually harm it. A heatsink and cooling fan are an important part of the system for dissipating the heat that builds up. Case fans in the system unit help to keep the entire system cool. Be sure that you don't block the air vents of a computer. The system unit is the case that contains the power supply, motherboard, processor, and the memory of the computer. Drive bays hold storage devices such as hard drives and DVD drives, and ports for peripheral devices such as a keyboard, mouse, or game controller to connect the expansion cards on the motherboard. The main circuit of the computer is the motherboard. The CPU sits on top of the motherboard. Other parts of the motherboard include the drive controllers and interfaces to connect to disks, expansion slots to connect adapter cards to the computer, data buses over which the data flows, ports and connectors to attach peripheral devices to the motherboard, BIOS, basic input-output system, and CMOS, a complementary metal oxide semiconductor, which stores the startup information for the computer, and the random access memory, RAM, currently used by the computer to complete its tasks. Drive controllers connect disk drives to the processor. SATA, Serial Advanced Technology Attachment, connects the internal hard drives to the system. But you may also find EIDE, which stands for Enhanced Integrated Drive Electronics Connections on older computers. Expansion cards fit into expansion slots on the motherboard to connect additional peripheral devices to the computer. Video cards, network cards, sound cards, and TV tuners are common expansion cards. Data buses are wires on the motherboard that carry the data between the components of the computer. The speed of the data bus is an important factor in the performance of the computer. Ports on the motherboard connect peripheral devices such as the keyboard, mouse, a webcam, scanner, and printer to the computer. You may be familiar with the USB or Universal Serial Bus port. Up to 127 devices can be connected to a single USB port, and many computers have more than one USB port. USB devices are hot swappable, meaning you do not have to power down the computer to remove them. Some USB devices are also powered through the port. FireWire, or IEEE 1394, is hot swappable and can connect up to 63 devices per port. FireWire enables devices to communicate in a peer-to-peer configuration without the use of a computer. It can power devices and it features high data transfer speeds. Thunderbolt carries both PCIe and DisplayPort video signals on the same cable, so it can be used to connect many different types of peripherals to a computer. Bluetooth is a short-range wireless technology used to connect devices such as headsets, mice, keyboards, printers, and game controllers. The BIOS chip on the motherboard is read-only memory, or ROM. It is non-volatile and used to start the basic operations of the computer when switched it on. Non-volatile memory does not require power to keep the data. The settings for the computer are stored on the CMOS, complementary metal oxide semiconductor chip, which is volatile memory. but the computer has a battery so that it does not lose the data when the computer is turned off. Memory boards are circuit boards that plug into the motherboard. DIMM, Dual Inline Memory Module, is typical on desktop computers. SODIMM, Small Outline Dual Inline Memory Module. Memory is used on notebook computers. Generally, memory boards can be added to a computer to improve its performance. Cache memory stores frequently accessed information, and it works at a faster speed than other types of memory. It is placed close to the processor, so data transfer time is reduced, improving performance. An input device enables you to input data into the computer system for processing. A keyboard translates the keystrokes you make into a signal the computer understands. The QWERTY keyboard is standard and one on which most people learn to key, although you also get other specialized keyboards. Keyboards contain letters and numbers, along with additional keys for special purposes. The escape and the function keys are examples of keys with special purposes, and the purpose of the function key can change based on the software application. Modifier keys are used in conjunction with other keys. Toggle keys turn a feature off or on when pressed. Ergonomic keyboards support the wrist in a more natural position as you key. Keypads, such as numeric keypads, are useful if you type a lot of numbers. Pointing devices make it easier to use a GUI format by enabling you to point and click. A mouse contains buttons and a scroll wheel, which translates movements into commands the computer understands. An optical mouse detects motion by bouncing light from a red LED light emitting diode off the surface below it. While a mouse might be the most familiar as a pointing device, you will find other options in a touchpad or touchscreen. Popular notepad book computers, a touchpad is used by moving the finger across a touch-sensitive surface. Devices such as tablets, smartphones, and handheld game consoles have touchscreens, which you touch with the finger or stylus to interface with the computer. An interactive whiteboard is a large-scale screen that enables you to interact with the computer by touch or with special pens. Digital cameras are input devices which can have limited features or be very sophisticated. Point-and-shoot cameras have an LCD or liquid crystal display to help you frame your image. These cameras do not have a flash or optical zoom features. They have a shutter lag, which is the time between you press the button to take the photograph and when the actual image is captured. Advanced point-and-shoot cameras have more features, including video capabilities, image stabilization, and burst mode. Compact system cameras, or CSCs, feature interchangeable lens, some manual controls, optical zoom lenses, the ability to capture high definition video, and connectors for an external flash microphone or viewfinder. Digital single lens reflex cameras have the features of a traditional high-end camera. You can change lenses, make settings manually, use a flash, frame the photograph through a viewfinder. Webcams are specialized video cameras that are used for online communication using a computer. Many notebook computers have webcams built into the case. Digital video cameras have more features and better quality video than webcams. Video from digital cameras can be edited on your computer and shared on the internet. Scanners of all sorts provide input to the computer. You probably use a scanner on a regular basis as you make purchases and pay with a credit card. Scanners increase the speed and accuracy of data entry. An optical scanner converts a paper document or photograph into a digital format. Handheld scanners are similar in function, scanning UPCs or SKU codes into a computer. A QR code, quick response code reader, enables you to scan a digital code using a mobile device and connect to the internet to find out more about the item. Barcode readers on mobile devices can help you compare prices using the internet. radio frequency identification, is used to track inventory and enable you to complete transactions without swiping your credit card. An RFID tag, which has a tiny antenna for sending and receiving a radio frequency, is embedded in an item or packaging. A magnetic strip reader reads information encoded on a magnetic strip. Gift cards, credit cards, and hotels use this technology. Biometric scanners read human characteristics, such as a fingerprint scanner or your optical scan, the eye. Near-field communication, or NFCs, enable devices to share data by touching them together. Microphones are input devices that convert sound into digital signals that can be transferred or saved with the computer. Microphones are often used as one of the features on a notebook computer. Game controllers and joysticks are used as input devices for video games. Adaptive input devices enable people to interact with computers using a mouse and a keyboard. Examples of these devices include braille writing machines, eye-driven keyboards, trackballs, mouse sticks, and on-screen recognition software. Voice recognition software enables you to verbally control a computer. Wearable tech enables hands-free computing and includes virtual reality headsets and smartwatches. Information generated by a computer is returned to the user as output. Monitors are video output devices similar to TV screens. The resolution of a monitor is the number of horizontal pixels by the vertical pixels. The higher the resolution, the sharper the image. Plasma screen monitors pass an electric current through gas sealed in thousands of cells inside the screen. OLED, or organic light emitting diode monitors, have thin panels of organic molecules sandwiched between two electrodes. Mobile devices, or active matrix OLED monitors, produce sharper images with a wider viewing angle. Projectors are devices that enable large groups of people to view the output. An LCD projector passes light through a prism that divides the light into three colored beams: red, green, and blue. Adapters and ports are needed to connect projectors and monitors to the computer. The display adapter is also known as the video card. Add notes or a script to help you land your message clearly. Notes can be added while editing your presentation and displayed in a teleprompter and presenter view while recording. Audio output is delivered to the computer using speakers or headphones, which convert digital signals into sound. A headset is a combination of headphones and a microphone. Adaptive output devices assist people with disabilities as they use the computer. Speech synthesizer screen reading software can read text to the user. Closed captions enable people to read a conversation taking place on a video. A braille embosser is a special type of printer that prints in braille so that text can be read by touch. Hard copies or printouts are printed on paper and represent output from the computer. There are many types of printers for various types of applications. Inkjet printers spray drops of ink onto the paper and can print in color. While the printer is inexpensive to purchase, the cost of ink cartridges can be costly. Communication devices are input and output devices that enable you to connect to other devices on a network or to the internet. You use a network adapter to connect your computer to a network. A wired network adapter is an Ethernet card that has a connection that resembles a telephone jack. Wireless adapters connect your devices using Wi-Fi networks. A modem or modulator-demodulator connects a computer to a telephone line for dial-up internet access. A cable modem connects to a cable system instead of a phone line. Computer data storage comes in many sizes, from massive network drives to small portable devices you can carry in your pocket. Optical disks are removable storage that use a laser to store and read the binary data. Solid-state storage is non-mechanical with the data stored on a non-volatile flash memory. This technology is found on flash drives that connect to a USB port on the computer or in memory cards, which use a card reader. The type of memory card you use depends on the device. Common formats include secure digital, SD, compact flash, memory sticks. Computer hard drives store the majority of the data on a computer system. This is non-volatile storage that can be in the hundreds of gigabytes or terabytes. The data is found magnetically on metal platters that are stacked on the hard drives. Read-write heads glide over the surface of the platters, reading and writing data. In this chapter, you explore the hardware of a computer system, beginning with the central processing unit, which is the brain of the computer. The motherboard is the circuit board over which data travels. It also enables devices such as disk drives, keyboards, mice, and printers to be connected to the computer. Devices attached to the computer can be divided into their functional areas of input, output, and storage. With input devices, you provide data to the computer. Output devices produce the information that comes from processing. Storage devices enable you to save the data even after turning off the computer or exiting a program. Thank you.